Remainder theorem. So the remainder theorem is so simple, or it's a shortcut to find the remainder. Remember, in long division, where figure would find out the end without the remainder, and also in synthetic division. So this one is simply just a shortcut. So using the same concept of x minus k as a standard equation for this part, and we'll be getting 1 negative k, then we will use k, and if it's positive k, we use negative k. So in this case, we say 2 times 2, which is to the power 3, minus 3, 2 squared plus 4, 2 plus 5. So 2 to the power 3 is 8. Is 8. 8 times 2 is 16. So let's just write 16. We just write 16 minus. So this is 4. 4 times 3 is 12. Plus this is 8 plus 8 plus 5. So 16 minus 12. That's 4. 4 plus 8, or 4 plus 5, that's 9. 9 plus 8, that's 17. So answer here is 17. So we can find the same by using synthetic division. And so synthetic division we do this. So which is there's 2, negative 3, 4, and 5. So the 2 comes down, it's going to be 2. 2 times 2 is 4. 2 times 2 is 4. Negative 3 minus 4, negative 7. Okay. Oh no, it's negative 3 plus 4. Negative 3 plus 4 is going to be 1. 2 times 1, that's 2. 4 plus 2, that's 6. 2 times 6, that's 12. And 12 plus 5, that's 17. You can see that we've gotten the same thing. And we can use long division as well. Long division, x minus 2 to x to the power 3 minus 3x to the power 2 plus 4x plus 5. Plus 5. So x into, just going to do this quickly. So x into 2x to the power 3, that's 2x to the power 2, that times x, it's going to be 2x to the power 3, to the power 3, then 2x to the power 2 times 2, negative 2, that's negative 4x to the power 2. It's going to be 0, so when we subtract, it's going to be 0. This is goes to x to the power 2, and the 4 drops, negative, I say the 4x drops, it's going to be x plus 4x. When we say x into x squared, that's x plus x. X times x, that's x squared. X times negative 2x, that's negative 2x squared. No, sorry, negative 2x. And we subtract, it's going to be 6. the 5 comes down. 2 into 6x, that's 6. So plus 6. 6 times x, 6x. 2 times negative 2, that's negative 4. So what do I do that? Oh no, this is for the other thing. This is something else. I mean 6 times negative 2x, that's negative 12. Right? Negative 12. Then we subtract. This is going to give us, this is going to be 0. Then we have 5 minus negative 12. It's going to give us 17. So you can see that all methods, the remainder theory, and the long division and the synthetic have all given us the same remainder, and as well as the same figures here. Let's try this one. This equation is polynomial function divided by x plus 3. So we can start with remainder theory. So we're going to have negative 3 here. So remember if it's positive here, then we use negative 3. If it's negative, then we use positive. So in this case, it's positive. So we use negative 3 plus 3, negative 3, the power 3 plus negative 3, the power 2 minus 2, negative 3 minus 6. So this is equal to 81. 3 to the power 4 is 81 plus 3 to the power 3 is negative 27. Negative 27 then 3 is negative 81. So negative 81 plus 3 to the power 2 is 9. 3 times negative 3 times negative 2 is positive 6. Positive 6 minus 6. So you can see that this cancel out, and our remain with 9. So you can use the synthetic division method to find the same. So we're going to use negative 3, and we got 1, got 3. I'm getting the coefficients. We got 1, we got 3, we got 1, we got negative 2, and we got negative 6. So the 1 drops, is 1. 3 times 1, that's negative 3. 3 plus negative 3, that's 0. 3 times 0, that's 0. 1 plus 0, that's 1. Negative 3 times 1. Negative 3 times 1, that comes to negative 3. 2 plus negative 3, that's 5. That's 5. Negative 5. Negative 3 times negative 5, that's 15. And 6, negative 6 plus 15, that is positive 9. You can see that contain the same. So we'll get the same thing if we use long division. So let me just verify that. So x power 4 plus bx minus power 3 minus 6 divided by x plus 3. So x into x is to the power 3. So x into x to the power 4. Then you multiply, giving us back x to the power 4. And x to the power 3 times 3. That's going to be 3x to the power 3. So subtract is going to be 0 plus, then we drop the x. So x into 0 is 0, so plus 0. 0 times x is going to be 0. 0 times 3, that's 0. Then minus. So x to the power 2 minus 0, that's definitely x to the power 2. And this goes down, negative 2x. X into x to the power 2, that's x. X times x squared. X times 3, that's positive 3x. We subtract. It's going to be negative 5x. Then this drops, negative 6. And we say x into 5x, that's negative 5. Negative 5 times x, it's negative 5x. 5 times 3, that's 15. Negative 15. Then subtract. Negative 5x minus negative 5x, that's 0. Negative 6 minus negative 5 is going to be 9. You can see that we've gotten the same answer. So the remainder theorem is simply a shortcut. Instead of using all these, it's simply if you're taught to find the remainder, you can use the remainder theorem, which is way shorter.